Dear students, in last some lectures we have already started the statistical mechanics lectures. So today I am going to teach you very important topic in statistical mechanics. It's nothing but ensemble. So there are different tools to study the statistical mechanics, in which one of the best or important tool is called ensemble theory. Gibbs, the scientist Gibbs introduced this new idea of called ensemble. What it mean by ensemble? So ensemble means it's a collection of larger number of macroscopically identical but essentially independent system. We already know statistical means it's a macroscopical study of a system by treating or by studying the microscopical behavior of the atoms or molecules. So in which suppose we have a system, it has macrostate and also it has a microstate. So we know what it means by macrostate means is a larger, suppose a system has a total number of particle n and it has a volume v and it has a energy E. So E, V, N, such parameter we call macrostate. And what is meant by microstate? Microstate means a system means it's a collection of molecules or atoms. So atom has a one atom has a position and adds a momentum. So in that way a larger collection of atoms or molecule has position and momentum. Each time the position and momentum is keep on varying. So by describing its the total all particle position momentum is called one microstate, and at some time microstate is different, so its position and momentum is changing. So in that way that is a microstate. So what is meant by ensemble? Here the ensemble means it's a system and it's has a macrostate, and suppose I took the duplicates of the same system. Our take is a mental copies of the original system, and I took all the system together as a collection. That collection is called ensemble. Did you get the point? I repeat one more. Suppose I have a system with a macrostate. I took its Xerox copies, first copy, second copy, and third copy, and so on. In that way, I took a larger collection of copies. So what is the difference? All copies are the same macrostate, but each copies as differ with its microstate. So suppose a system has a larger type of microstate. So all copies are the same macrostate with different microstate. So it means I take a collection of larger number of macroscopically identical but essentially independent system. Independent means it's independent from each microstate. So such a system, such a collection of a system is called ensemble. So what's the importance of ensemble? Suppose in thermodynamically, to study a system we need its time average, or it's depend on time. But what happen in statistically, one changing the time, we keep on changing time, its microstates keep on changing. So microstates keep on changing, so we cannot take a time average with it's not easy to take time average. So Gibbs introduced this new idea. Here instead of taking time average, if you have an ensemble, we can take ensemble average. How? At one instant we have all the possible microstate as a system. So at some instant we took the copies of all system with different microstate. Possible all microstates are getting at the same time. It's an imaginary concept. So if we have an ensemble, we can take an ensemble average instead of taking a time average to study some parameter of any system. So this is idea of ensemble and why we are taking ensemble. So and another thing, we can treat in system in different manner. So here mainly in statistical mechanics we are going to take three different kinds of ensemble, in which one is called microcanonical ensemble, and second is called canonical ensemble, and third type of ensemble is called grand canonical ensemble. I will tell what is the main difference between these three. So I will microcanonical ensemble first. It's a collection of essentially independent system having the same energy, same volume, and same number of particles. E, V, and N are same. And so so I drawing a picture there. I'm showing a picture here. E, V, and N, and or separated with, each system is separated with rigid, impermeable, and well insulated walls. The boundaries are insulated and impermeable and rigid. Why? This E is constant, so it's a insulated walls, and it's when N is constant, or number of N is not exchanging, so impermeable and as a rigid boundaries are there. So such collection of system or ensemble is called microcanonical ensemble, in which total E, total V, and total N are constant. So the second type is canonical ensemble. What is meant by canonical ensemble? Canonical ensemble means here instead of E I took T. E can exchange between the system. So total temperature T, total V, total N, total volume, and total number of particles are constant. So E can exchange. So this is not insulated, it's a diathermic walls. Boundaries are diathermic. It can conduct in between the system. So the system, collection of system with the T, V, and N are constant is called canonical ensemble, in which the boundaries are separated with rigid, impermeable, and diathermic. So diathermic means conducting walls. So this is a different second type of ensemble is called canonical ensemble. And I will deal the third type, grand canonical ensemble. It's also a collection of system with independent system with same temperature, same V, and the third parameter is called chemical potential. Here E and total N are not constant. E can exchange, so its boundary means diathermic, and also N can exchange. Total number of particle from one system to another system can move. So as we call permeable. So all particles with T, collection of particle with T, V, and chemical potential. Chemical potential is some potential for molecules, same like or gravitational potential or electric potential. So chemical potential is another parameter. You just go to and point out that a potential is there, chemical potential. I will explain later what it means by chemical potential. So any collection of system with T, V, and mu is a constant is called grand canonical ensemble, in which the system are separated by a rigid, permeable, and diathermic walls. So these are the three different kinds of ensembles. So I hope you got the idea of what you mean by ensemble, and why the theory of ensemble is needed in statistical mechanics, and what are the main three different kinds of ensemble. We will going to the further study. So this is a small lecture on ensemble. So thank you, and you just read on the further about the ensemble. We will meet in the next lecture in the next class. Thank you.